Perfect. Welcome, guys, to an introduction to Node.js and Express. My name is Sean Kirkby, and I'll be your instructor for this backend section on Node.js. And I'm really looking forward to it. No need to necessarily answer, but who's sick of React, right? Some of you will probably find that this section is more to your liking. I'm definitely more of a back-end developer than a front-end developer. I don't have a strong sense of design. But that being said, I do love the technology of React and the front end in general, and Angular and others, and JavaScript in general as well. So I think you're gonna have a great time. So let's see, what we're gonna do to get it kicked off is, before we start talking about the topic, I want to post something in Slack. There's a link to Slido. We'll have a few questions later in the class that you'll be able to answer, and that's the method that we'll do. We may have some impromptu ad hoc questions that we'll cover, that will come up as we go through, and we'll have you answer those in Slack, but I'll mention that when that's the case. So go ahead and open that Slido. One other thing that I want to do is something that you're going to want for today is to have Postman downloaded and installed. If you haven't done that yet, I'll post the link to that, and make sure you have that before we get to that part of the class. Have that downloaded and installed. I'm assuming that you each will have also some kind of editor that you'll be able to manage writing code in. I use VS Code. That's a very popular system. It works for Windows and Mac, as well as Linux if you have Linux on the desktop. And you'll probably find it easier to follow along if you also are using VS Code. So hopefully that'll work out well for you. Somebody asked a question, can we use Insomnia instead? And absolutely. If you're familiar with Insomnia instead of Postman, you're welcome to use that. I'll be using Postman in class. I would recommend Postman if you're not familiar with Insomnia, just so you can follow along. But if you know Insomnia, then by all means, feel free to use that. And I will also point you to a few other resources that you can use. You'll probably want to, before the class, before the overall class, not just this lecture, but the next 6 weeks before we're done, you'll be able to have some familiarity with a number of different systems. So another question, Aaron asks, what is Postman? And the answer is that it's a simple HTTP client that we'll be able to use to test our APIs in our backend as we get through it. So I'll explain a little bit more about that when we get to that part of it. That's a good question. So one thing I want to do also for now, I'm starting to get some questions here in Slack, and I think that's fine. But just so you know, I'm going to be probably paying most attention to Slido. So you'll probably get a better response if you ask questions in Slido, unless I prompt you to answer a question in Slack. You're going to want to use Slido to ask questions, and then we'll have some polls that I'll do through Slido as well. So that link that I posted earlier, feel free to jump in on that. All right. Okay, so let's dive into, let me just make sure I'm looking at the right thing here. Okay. So let's dive into to the topic. So we're going to talk about Node.js and Express. And our objectives for today are to allow you to understand what Node.js is and what its core features are, what Express is and its core features. We're actually going to create a simple API. It says here that can respond to GET requests. But we're going to actually go further than that. As it says here, we're going to build a CRUD web API. I've got a question about CRUD later. We'll get some responses on that. And then, of course, it says to use Postman to manually test our APIs. I will use Postman. Others can use Insomnia, and there are other things that we could use as well, but Postman is what I'm going to focus on for today. So we'll get through all of this, and that'll prepare you to be able to do the project for this session, and we'll briefly go over that as well to help you out. Okay, a little bit about me, just to give you a little bit of context of where I come from. I've been in the industry for a very long time. I started writing code, I want to say probably 1982 or something like that. If you don't count the programmable calculator that an uncle bought me when I was 13. So I'm old compared to a lot of you. I'm really old, but very active in the industry. And I love this. I think I really have a lot of respect for you guys for wanting to dive into an industry that's fun, it's creative, it's fulfilling. Rewards will come financially, down the road, even immediately. But for me, that's the satisfaction really comes in being able to create something that makes life better for other people and that they can use, and doing an excellent job. What you'll find as we kind of go through the topics is that I'm not going to be able to answer every question that you have. I'm not going to be able to expose you to everything there is to know. But my intention is to lay a foundation that will prompt your curiosity and allow you to intelligently ask questions from other sources, as well as me. I'm happy to help out. But stay curious, and if you find that you're bumping up against limitations of understanding, just reach out, talk to your TL. Feel free to reach out to me, reach out to each other. And there's typically, there's always a way that you'll be able to get to understanding it, and know that that's just part of the challenge. It's something that is always going to be there. I still run into things that I have to spend some time grokking in order to fully understand. So someone asks a question: in a programming battle to the death, which one of you would come out on top, me or my brother Brian? So I think you guys had him, Brian, in the last class. If you were curious, yes, we are related. We're brothers. And I'll say I started first and got him involved, and then he eclipsed me. He's very smart. We kind of took different directions. I started a company, and he came and worked for me for a little bit, and then we both, when we closed that down, went back into the industry. And I have gotten what some people would call the management lobotomy. I manage engineers, but I still dive into the code and love to be involved in that. So I would say that more than likely, he'd probably be able to outdo me in a programming battle. That being said, I'm far more diplomatic than he is, so I'd probably be able to convince everybody that I won. So we each have our different strengths. Fun question though. All right, so let's dive into this. So we've talked a little bit about what we're going to be learning as we go. I'm going to jump into a live poll in Slido. So if you'll head over there, I want to ask a simple question. So our intention in today's class, in fact, in the next 4 classes, is to learn how to build a web API. So I want to start with a question. And so I've started an active poll in Slido, and the question is, what is an API? And more specifically, what is a REST API? So if you guys will take a minute or two and just post some answers based on your own study, your own knowledge. Don't be afraid to guess if you're not certain, but you think you have an idea. I'm not seeing any responses yet. I'm not sure if you guys are in Slido. There we go. API. So somebody, there we go. We're starting to get some responses now. So it's a way to talk to the server. Not quite sure what a REST API is. Application Programming Interface is what the acronym stands for. We'll talk a little bit about what that means. It allows you to interface with the program, okay, using pre-configured endpoints. That's correct. API stores data. That's, I would say API is more how you access data that's been stored. And we'll talk a little bit more about that. It's a good perspective, but not quite accurate. Let's see, what else do we have? API is the server. And that's one of the things that I think is important for you to recognize and understand is the difference between an API and the processes that are communicating together. The client is not the API and the server is not the API. The API is how the server allows the client to talk to it. Okay, so there's a difference between the API and the server, but they are very tightly related. Okay, it specifies how components interact. That is true as well. Okay, uses endpoints. That's not always the case. When we talk about web APIs, there are endpoints. In fact, with any API, I think you're right. You're correct. We could say that any API has an endpoint or multiple endpoints. But typically, when you think of endpoint, you think of network communication and protocol. Not every API has that. In fact, in the early days of programming, network programming was very new and not very common. Typically, people went down to the store and they bought their software in a box on disks and they brought it home and they installed it. And you may have different applications installed on your computer that were communicating with one another over an API, and there was no network communication involved. But the concept of an API is still active, right? Still at play with what we're doing. And so then somebody says REST is an architecture for APIs. That's also correct. REST is a style of creating web services. That's also correct. So we're going to dive into that as we go through this class. So good answers. Thank you, guys. I'm going to go ahead and close this poll. Okay. So what we're going to talk about is how to use something called Node.js and Express.js to build APIs. Okay. So I'm going to start another poll on Slido and in just a second here, but just to talk a little bit about Node.js. When you think about a browser and what you just went through with React and in the last two sessions in Web Application 1 and 2, you've been developing in JavaScript, and that JavaScript is code that is ultimately executed by the browser. And there are different browsers, and depending on how you learned about it, you understand that there is a JavaScript engine built into the browser that knows how to take that syntax and turn it into executable code that can run on whatever operating system and hardware architecture the browser is running on, whether it's on a Mac or on Windows or on Linux or any other operating system that happens to have a browser that can execute JavaScript. It turns out that when it comes to Chrome, as an example, as a browser, there are different groups at Google that develop the browser and the JavaScript engine that goes in the browser. So the Chrome team is using a JavaScript engine inside their browser in order to execute JavaScript. And that JavaScript engine is the thing that knows how to take JavaScript files and JavaScript syntax and convert it into code that can execute on the machine. In the case of Chrome, that engine is called V8. That's the name of that engine. And there are many other JavaScript engines out there. V8 is a popular one because of how quickly it runs and how solid and secure it is. And but other browsers use different engines. So when you look at Firefox and you look at Safari and you look at Opera and you look at any other browser out there that can execute JavaScript, they aren't necessarily all using V8. They may have different JavaScript engines. One of the nice things about V8 is it's developed in a way that allows you to embed it in other types of applications. And somebody had the idea, I already know JavaScript. I've got a good solid understanding of the JavaScript syntax and how to write applications in it. Why does my JavaScript have to run in a web browser? There are other languages that are used to create back-end processes or server processes that don't have a user interface. They are processes that do things like work with data or execute functions and then return results. they aren't really interfaced by the user. There's not a user that's sitting there manipulating these back-end processes. And languages that are typically used to create that include C++ or C. It could be Python. It could be C# or other .NET languages. It could be Ruby. There are many others that can be used to create back-end processes. And somebody thought, well, why not JavaScript? So what they did was they took the V8 JavaScript engine and turned it into an environment that can do exactly what your browser does, and that is execute JavaScript files, but without a browser interface. And so all of the capabilities of processing and communicating that you can do through JavaScript can be done in this environment, and the environment is called Node.js. Okay, so if you go and look at the Node.js .org website, you'll see right at the very top here, it says Node.js is a JavaScript runtime built on Chrome's V8 JavaScript engine, right? You can read all about V8 here if you want. It has its own website that explains everything about it and what standards it supports and so forth. And so when you look at Node, there's a couple of different versions. You've got the 12.13.0 LTS, which stands for long-term support. And then there's this current version that's considered to be kind of the bleeding edge, latest and greatest, but not necessarily most stable. What I have installed currently is 12.13. I'm not sure what you'll have on your machine, but if you don't have Node installed, you're going to want to download it and install it from this website because Node is what we're here to learn about. And so hopefully you have that already installed. Notice that it comes up automatically for me to download for Mac OS. That's because the browser detects that I'm running on a Mac. If you're running on Windows, you'll get a different download here. Okay. Let me take a quick peek. All right. Let's bring this back over here. Somebody asks if I would suggest the earlier version. Yes, I would. 12.13 is what I would suggest simply because it is more stable. If there are certain features that are being added to Node that you want to take advantage of that haven't been released yet in the long-term support version, then you can look at 13.0.1. But when it comes to writing software that you want to be stable and reliable for a long time, without whoever owns that software making a lot of changes to it, then the long-term support is the one that you want. But if you're looking for checking out the latest features, you can look at the changelog for the current version and try that. But I would not release software on the current version necessarily. There may be libraries that you want to use that haven't been tested against the most current version, so that you can run into some danger if you use that. But sometimes that's what we need to do, and when you run into that, then you just have to kind of slog through it. There's also an application that you can download. I won't go into that and cover it here, but there's an application you can download that will allow you to manage multiple versions of Node running on your computer at the same time, and you can choose different Node versions. So if you want the long-term support version plus the current version installed, you can have them both. But for our purposes, I'd recommend 12.13. That being said, if you have 13.0.1, I don't think you're going to run into any problems. But if you do, then we may need to have you switch back. But we'll see how that goes as we go. All right. So we talked a little bit about Node.js. I'm going to start a poll on Slido. I'd like to get your responses to this. And the question is, what are the uses of Node.js? So I talked about building backend software, but based on your own study and your own experience, what would you say are the uses of Node? So JavaScript outside the browser, correct? Okay. So running JavaScript outside the browser is the main purpose of it. But what kinds of things do you think you would build with it? So we're talking about APIs, but what are some other things you think you might build with Node? Building an API, good. Allows us to have consistency with the front end and the back end languages. And that's, I like that answer for a couple of reasons. One is it highlights the nature of an API. When it comes to writing an API, if it's a good API, it shouldn't matter what the language, what language the back end and the front end were created in. And that is the case with Rust-based APIs or HTTP-based APIs, which we're going to learn how to do now. The biggest benefit I think you get with using Node.js on the back end is it allows you to leverage skills that you already have. And those skills can extend beyond being able to write software and create systems, but also being able to interview people that are developers. If you're a shop that really understands JavaScript and you've got some really strong JavaScript team members, then it's going to be easier for you to recognize other strong JavaScript developers that you want to bring into the company, whether they're front end or back end. And it allows them to be more fluid in terms of what projects they could be supported or assigned to. So that'll be true for you guys as well, being able to leverage JavaScript. Okay, so someone mentions IoT. That's awesome. There's actually, and so someone says you can build an actual server with Node, and that's correct. You can. There's also an architecture or a method for creating software that you can consider that is called serverless. So if you look at Amazon Web Services, for example, they have a service called Lambda, which essentially lets you write small snippets of functionality in different languages. And those snippets come into existence when they're needed, and then they disappear. And so rather than having a server that's constantly running, you can have these little chunks of functionality. You can stitch them together and create an entire system without a server that they're running on. And their cost model is very interesting when it comes to that. And one of the languages that you can write your Lambda functions in is Node. While it is true that you can create an entire server with Node, it's also true that you can create an entire serverless system using Node. So that's kind of an interesting use of that. All right. So enough talking about it. Let's talk about our project for tonight, and then we'll talk a little bit more about what we're going to be doing this evening. By the way, just to mention a little bit about REST. REST is an acronym that stands for Representational State Transfer. And essentially, what a REST API is it's a method for allowing a client and a server. The server is a process that has some functionality that it can make available to other applications that want that functionality. Very often that functionality is the storing and retrieving of data. Sometimes that functionality is compute processing. Sometimes that functionality is communicating with other systems on your behalf. So if you have a server that can supply some functionality, it's serving that functionality up. And then the client is the process that's using that functionality. The API is what they use to communicate. A REST API is an API that allows the server and the client to communicate using HTTP. There are a number of different reasons why that's very helpful to us. And if it sounds a lot like a web browser and a web server, that's because it is exactly like that. In some respects, you could consider what web servers make available to be a REST API, but without getting into a lot of the really strict details of what it means to be a RESTful API, I would say that the API that a web server serves up is really more REST-like. It's not strictly RESTful. But I'm not going to dive too deeply into why that is. Feel free to study up on that on your own if you're interested. And I will also say that there are currently today some interesting movements away from REST for a variety of different reasons. But one of the main benefits that we get from a REST-based API or an API that's based on HTTP is that the entire internet infrastructure, the servers, the routers, the caches, is all tuned to efficiently handle high volumes of HTTP traffic. And so when you have an API that's based on HTTP, you get to take advantage of all of that for free. When I say for free, I mean it's just all built into everything that's between you, your server, and the client. We'll talk a little bit more as we go through the class and later sessions about caching and how that can come into play and the benefits there. And what all the headers in HTTP packets do, or how they work. We're going to go into that a little bit today, but we'll continue to discuss that throughout the class. But basically, just know that REST APIs are APIs that are based on HTTP, and we'll talk about building a CRUD API and exactly what that means here in just a little bit. Okay. All right. So let's talk a little bit about Express. When you looked at working with React, one of the things that that you became familiar with was a library and a system called Axios. And Axios was a system that allowed you to make HTTP requests and receive responses. It turns out that there's quite a bit that goes into being able to parse and understand headers in HTTP to make sure that the data that you're sending is all accurate and packaged properly, being able to detect successful responses versus error responses. It's not required that you use Axios to send an HTTP request from your React application to a web server or an HTTP server and to receive the response. In fact, Axios is built on top of other lower level HTTP services in order to do what it does. But what React does is it makes a lot of the minutia around, or the the small detailed things that you have to take care of in order to successfully communicate with an HTTP server. Axios makes that easier. That's essentially what Express does for us on the server side. Likewise, we can create an HTTP server without Express using Node. But there's a bunch of little things that you have to always do to make sure that you've got a fully working server. And if I'm honest, I'll tell you that I think it's a good exercise for you someday to build an API without using Express, just to get familiar with what's happening underneath. But for our purposes, we want to get quickly to the concepts of understanding how to build an API and learning how to use Express, because it makes things a lot simpler for us. And so we'll get a chance to dive into what Express is and how we can use it to make it easier to build an HTTP server that makes a REST API easy to implement. Okay, so we're going to dive into that. Let me pause there and invite you to ask any questions if you have any. Someone asks, how does HTTPS work into this? Good question. HTTPS is basically HTTP over a secure communication channel. So from our perspective, HTTPS is handled between the client and the server in terms of doing certificate swapping and encrypting and decrypting of the traffic, so that on the wire, while those packets are being transmitted, the data is completely encrypted, and therefore it's not susceptible to what's known as a man-in-the-middle attack, where somebody who might be working for a company that owns one of the routers that your traffic is going to go through might be able to have access to that. And if you're like me, you might for a long time be thinking, well, who would really care about any traffic I have to send? But as soon as that traffic includes your bank account number and your login name and password, all of a sudden it's very interesting to a lot of different people. And there are many other people whose bank accounts would be far more interesting than mine, but I still don't want mine exposed to anybody. So HTTPS essentially ensures that the traffic is encrypted, but we don't really have to worry about that. That happens down at a level, at the protocol level, that is taken care of for us. So there's a whole public and private key encryption system that plays into how that works to make sure that the data is encrypted. But other than that, there's no difference. HTTP and HTTPS have the same verbs, they have the same structure in terms of the protocol content. It's just that HTTPS is encrypted. If I can't access the node side, is there a way to update it from the terminal? If you've already got it installed, you know, it's a good question. I'm not sure if you can use NPM to update it. That's a question I may have to take offline, or maybe your TL can help you with that one. Be more concerned about how if you can't access the node side, I can't imagine that updating it from the terminal would be possible either, because you still have to get it from the website somehow. Okay. Thank you. Someone posted a link, and I'll put it over in Slack that you may find it helpful there. Okay. All right. Let's do a quick time check. One of the things that happens when you install Node is you get another system that comes along with it that's called NPM, which stands for Node Package Manager. NPM is one of the reasons why Node, I think, has been so successful. It is because it makes it very simple for somebody to create additional functionality like Axios or like Express, like SQLite connects and other things that we're going to learn about, and make those packages available to other developers in a very simple way. I can remember back in the day when I wanted to take advantage of somebody's package or system that they made available for Linux. I'd have to go hunt down every single dependency. So if they wrote a system that depended on 14 other different libraries, I had to manually make sure each of those libraries was installed and that I had the right versions of them installed. NPM takes care of all of that automatically for us. So when you install Node, you get the Node Package Manager with it. And we can use, in fact, we're going to use the Node Package Manager to be able to install some of the dependencies for our projects as we go forward. And today we're going to use it to install Express, and I'll show you how to do that when we get to that point. There's another package management system called Yarn, which is built on top of NPM. It uses NPM to do the actual work, but it makes some things a little easier. I happen to prefer Yarn simply because the syntax is a little simpler. But functionally, there really isn't any difference between the two. So I will make sure that when I use Yarn, if you're not using Yarn, or you don't have Yarn installed, that I'll make sure you understand how to do it with NPM as well. But that's essentially the role that they play, is it allow you to download systems or libraries or packages that you want to be able to use, and automatically manage downloading everything that those packages depend on, so you don't have to take care of that. In fact, we're going to see a really stark example of that when we initialize our project. Okay. Let's see. All right. So if you go to the training kit and click on the guided project link at the top, and then go to the GitHub repo link. If you haven't already done this, you're going to want to fork this project into your own GitHub repository, into your own GitHub account as a repository, and then you'll want to clone that to your local machine. My assumption is that you've already done that. If you haven't, please post links, and I will take a little bit of time to go through how to do that, or get with your TL. Your TL can help make sure that you know how to do that. But you're going to want to have a local copy of what's in this repo. So you need to click on fork, and then that'll fork it into your own account. And then once it's there, you can then use Git locally to download it from there. And what I will suggest going forward is that before lecture time, you're going to want to make sure that you have the guided project already forked and cloned locally or downloaded locally, so that you can be ready to go when we get into the project. Okay. So what I'm going to do now is take a brief break. We'll do a 5-minute break. If you don't have this repo already forked and downloaded to your local machine, please contact your TL and get some help with that. And within the next 5 minutes, when I come back, we should have everybody ready to go, and we'll dive into writing some code and getting started on our API. So I'm going to start a 5-minute timer, and we'll be back in 5 minutes. All right. Let's dive into building some code. So if you've got the package or the system downloaded, the guided project, then you should open your editor so that you're looking at the project here, and we can take a quick tour through what we have here. You will notice that we've got a folder called data. We have a get ignore file. We have a file, code file called connectsfile.js. There's a license file, a package.json file, readme.md, and yarn.lock. And then underneath data, we've got something called migrations and seeds, which we're going to ignore for today. We'll get into that later in the course. There's a file called hubs-model.js. We're going to take a peek at that a little later today. And then there's a SQLite database. So it's a database file that contains some data that we're going to be able to use as part of our project today. So basically what we're going to be doing is creating an API that allows somebody who's writing an application to access the data that's in this database. Okay. Connects is a system that allows us to write JavaScript that interfaces with this database. And in this case, it's a SQLite database. It's a form, a version or a type of database. Later, when we talk about data persistence, we'll talk about SQLite as well as other databases and how to create them. But today, it's included for us, so we don't have to worry about that. And connects is just the way that we use to provide, that gives us access to it. And then, as I said, we'll talk about this hubs model file and what's in it. Basically, this contains the functions that we're going to use to actually access the data. Those functions use connects to make that possible. And then we'll ignore the license file. It's not really relevant to us for right now. Package.json is our manifest file. I'm going to open that. We'll go through this here in just a little bit. Readme.md is what shows up on GitHub when your project is up there. And then we'll talk a little bit about yarn.lock in a second here. So somebody asks, what if connects is not in my file? And I think the question you're asking is, what if if you don't have connectsfile.js? Is that the question that you're asking? And if it is, I'm not sure if you might want to check with your TL on that and see if they can help you find it, because it is part of the repo. So if you cloned it and downloaded it properly, you should have it locally. So maybe your TL can help you track down what might be happening there. Okay. All right, but it should be there. So package.json is a file that basically is a manifest that describes our application. So other systems can use package.json to explain to other systems what version our package is. It provides a text-based description. It says what the main file is. There's something called scripts here, which we're going to talk about. Repository information, keywords, which help in searching so other people can find it. A lot of this is really meant for if and when we deploy and publish our package, if it's meant to be used by other people. So we're not going to dive into what a lot of this means or how it's used, because that doesn't really apply too much to us. But if you look at these two sections down here, the dev dependencies and the dependencies, these are other packages that our system depends on. Okay, one is called NodeMon, which we'll talk about here in just a second. And then, as I mentioned before, there's these packages, the Connects package and the SQLite 3 package, that allow our system to interface with the SQLite database. Okay, so those are things that if anybody is going to execute and run our server, they have to have these. And so the fact that it's in package.json tells the node package manager or Yarn that when somebody gets our package and they want to execute it, Yarn or Node Package Manager needs to download these dependencies automatically for them. Other packages that we use, like Express, which we're going to do here in just a little bit, have their own package.json files that explain what their dependencies are. And that's how Node, NPM, and Yarn know what to download so that our application can use Express without us having to manually go through and bring all the things in that Express depends on. Dev dependencies are just like dependencies. They're packages that we need or that we want in order to be able to develop our application. So this package called NodeMon is a monitor application that will monitor our source files. And every time we save a change to a source file, it will automatically restart our server. So if our server is running and we make a change and save it, it'll automatically restart it so the running server has our latest changes in it. So it's just a convenience. It's not something that we would deploy with our package, so it's not a dependency. Our application doesn't need it. It's just for us during the development phase, which is why it's listed under the dev dependencies. So it turns out that NPM and Yarn both have syntaxes that allow us to add dependencies and add dev dependencies. For this system that we've downloaded, that's already been done for us. And so the dev dependency and the dependencies are already listed here. We're going to add a new one here in just a little bit. But in order for us to be able to execute this, you'll notice, for example, that we need a package called connects, and we need a package called SQLite 3. And if we look through all of the stuff that we've downloaded, we'll find that we don't have connects in SQLite. We have a JavaScript file that we've created. Oh, we don't want git ignore. We want connects. This connects file.js, we created this. This is not part of connects. When I say we, I mean Lambda created it as part of this guided project. But nowhere in here do we find the actual connects package or the SQLite package. And so the question is, how do we get these downloaded? So they're listed here as dependencies, but how do we actually get them downloaded? And the answer is in either using NPM or Yarn. Okay, so if you're using Yarn as an example, then you would just type Yarn and press enter. And what that will do is go through and download all of the packages that we depend on. Okay. If you use NPM, I think the syntax is just NPM I. Okay, so if we do that, then what that's going to do is go through the process of downloading all of our stuff. Now, even though I said I typically use Yarn, I did NPM I just as an example. One of the things I like about Yarn over NPM is that Yarn is much faster. So if you are using Yarn, when you type Yarn, you'll find that it downloads things very quickly. There's some warnings here that we're going to ignore. They're not super critical for us, but if you just type Yarn as an example, you'll notice that that's going to go through and do basically the same thing and download all of the packages that we need. Okay. So you'll notice that what it does is it resolves the packages in order to understand what all of its dependencies are. It fetches them or retrieves them and downloads them, checks our dependencies again, and then it finishes. So one thing to notice that has happened since we've done that is a new folder here that was created called Node Modules. Okay, and if we expand that, you'll see a whole collection of things here that are dependencies. So the dependency chains run very deep, right? So if we all we did was import NodeMon, connects, and SQLite 3, and we'll see that a lot of these other things, all these other things are dependencies that connects depends on something, which depends on something, which depends on something, and you have these very deep dependency chains. And so all of this code is automatically downloaded for us. Okay. Among these things, you'll notice we have our SQLite 3 module, right? And we also have our NodeMon module, and we have our connects module. which is right here. Okay, and each of these is itself has its own node modules and its own source code and its own package.json file, right, which allows us to use it. So someone says the command I put in was yarn install. Once I put in yarn in the terminal, it showed up. So yarn is the right thing. If you want to just initialize it, to download all the dependencies, you just want to type in yarn. So I'm glad you figured that out. Is there a way to install a default list of dependencies like a simple button or command? So you can't get simpler than yarn or npmi. So if your package.json file identifies what the dependencies are, all you have to do is type npmi or yarn, and it will read the package.json file, identify what the dependencies are, and then go to work bringing everything down for you. Someone asks, is it best practice to uninstall dev dependencies prior to deployment? What I'll say is it's best practice to make sure that dev dependencies are identified as dev dependencies. There are packagers, things that will package up your application and make it ready for distribution to the public, that will automatically ignore the things that are in the dev dependencies section. So you don't really need to uninstall them. But as long as you've identified them as dev dependencies, then they will be ignored or left out when you actually package, if you use a packager. But in short, yes, your dev dependencies you don't want to distribute. It's just bulk for the most part. That's not necessary, and in some cases it could be a security problem. Some of the things that we use to make development easier for us can actually create security problems for us. All right. So we've talked a little bit about the structure of our application. Once we've got these dependencies downloaded, one of the things that you'll notice here is the scripts section. The script section allows us, when it comes to getting into the process of developing and testing our application, it allows us to create simple commands that can execute more complex commands. Now, it turns out that nodemon space index.js is not really complex, but a command of server is obviously simpler, and the concept is really important because you'll find, and we'll get into this as we get into other projects later in the course, that the scripts can be very helpful in terms of doing things like building our application or packaging our application or running tests rather than actually running the process itself. And in this case, we came pre-configured with a script called server that all it really does is it begins running our application, and it does it by using nodemon to load in node index.js. So nodemon will execute node and tell node to begin running index.js, and then nodemon will continue to monitor our source files, and anytime we make a change, nodemon will automatically restart the server for us, okay? So you'll notice that there's a couple of references here to a file called index.js. And if you look over in our code, you'll notice that we don't have an index.js. So the way that these scripts work, if I'm using yarn, for example, I would type in yarn and then the script name. Okay, and you'll notice that as soon as I did that, yarn tried to execute this same command here. But we ran into an error because it says it cannot find the module index.js, right? So that file is missing, and the error is module not found. And then nodemon says it's waiting for file changes before it starts, right? So it's actually still monitoring. I'm going to go ahead and stop it by pressing Control-C. But clearly what we need to do in order for this to work is we need to create an index.js file, right? So we're going to do that next. Before we do, I could see a question in here. How do we make our own package.json file? You can initialize a folder with that will, you can initialize a project folder that will create a package.json file for you as a kind of a skeleton or a template. I very often just copy an existing one and and then start working with that, because I typically have them set out with some dev dependencies that I want in every one of mine, that will automatically work that way. So you can just copy an existing one, but if you want, you can use npm to create a folder. And I want to say that the command is init, npm init. I think someone can check for me on that. I think that's the command. I'll get the exact answer for you a little bit later. But for the most part, I just copy it. Yeah, I think it's just npm init. So npm space init should create a package.json file for you. Yeah, so then somebody posts it's npm init and then a -y. You can do a -y. If you don't, then what npm will do is prompt you for this information, like what's the version, what's the name, what's the description, and some other information. And if you want to just take default values for that, you can do -y, and that way it won't prompt you for questions, and it'll automatically answer those for you. All right. So next thing we need to do is create our index.js file. So I'm going to click on this new file icon here and call my file index.js. So somebody asks, well, you need to type sudo first when installing in Linux. That depends on your configuration and what permissions you currently have in Linux. You might need to do a sudo. We're not going to cover that. Some people pronounce it sudo, just so you know, because it really is a do command with super user privileges. So if you don't have the privileges to do it, if your system's locked down a little more, you may need to do that. So it just depends on what permissions you have. So in our index.js file, we're going to keep it really simple and just do a console.log. I'll call it, just have it say hello world. Okay. And I'll save this. And now that we have an index.js file that exists, now I can do, by the way, if you want to do npm and you want to run that, you'll notice if you type npm server, you get an error, and it's basically saying the npm command that you're using doesn't exist. There are only a couple of script names that you can use as npm commands, start and stop among them. So if you want to use npm, you have to use the command run and then type in the script name. So npm run server, and you'll notice that it ran nodemon with our file, which executed node, and then our file did its thing, and now it's just sitting here waiting. All right, so if I come in and change, put an extra L, you'll notice that it restarts and does that for us. And again, the command for yarn, you don't need to type the word run, you just type yarn and then the script name. Okay. So there we can see we've got an index file that's working. Nodemon is happy because it can find the file and it's executing it. And we're off and running with respect to creating our API. Someone says, I use the touch command to create files and mkdir to create directories. What's the benefit of doing it the other way? If you're talking about the benefit of using npm init, it's just convenient. You can use touch to create files and make dir to create directories if you want. It's mostly just convenience. All right, so one thing that we know that we need is we know that we're going to need, and I'm going to open it back up my package.json file. One thing that we know that we need is that we need to use Express. We're going to need that as part of our package. And so in order to make that work, in yarn, you would just do yarn add express. And it not only adds yarn, but also all of its dependencies, express, but also all of its dependencies automatically get downloaded for us. And you'll notice over here in package.json, it added express as a dependency for us. Okay. For npm, it's npm install express or npm I express if you want to use a shortened version of that. and that will add the Express package for you and do the same thing, essentially. So someone said, why do we use yarn server instead of npm, or instead of yarn start? And that's a great question. It turns out in that for this, whoever created this guided project for us created a script called server. It's just what they chose to call it. It could absolutely be start, and that would make sense if we did. In fact, if I did that and called it start, then I could do yarn start, and then that would work. That would also make it so that with npm, we don't have to use the run command, right? So I could do npm start. It'll automatically find it, because npm start is a built-in npm command that automatically looks for a script called start. Okay, I'm going to change it back to server just because that's what we started with, but they're both the same. It's just what they did for us, so I just left it that way. All right, so now that we've added Express as a dependency, we want to be able to use it in our index.js file, right? So when we were working with React, there was an ECMA 2015 or JavaScript 6 version 6 syntax that we used to import packages. Okay, that you're familiar with, and it looked something like this. We might say import something like that, right? And that would create a variable called Express. It turns out that Node doesn't support this, and it uses something called CommonJS, which is has a similar functionality, but just a different syntax. Okay, and so the way that we do it in Node is we're going to create our variable called Express, and we're going to use a require function. Okay. And similar to our import command, if you remember before, you can import modules that were installed just by using the module name. And if your module happened to be in a local file, then you had to use the path to it. And it's the same thing here. In our case, Express is in the node modules folder. And so we don't put a path to it. We just name it, and it automatically brings it in, and we get a variable called Express that we can use. Okay. Now that we have Express, so basically what Express is, it's a variable that contains whatever is being exported from the Express module. Okay. And there are things that we can do with that Express variable, but what we want to do today is we're going to create a server process that we can execute that will begin listening for requests coming in from a client. Okay, so keep in mind that what Express allows you to do is create an HTTP server. So when we use Express, our application is going to become an HTTP server and will receive HTTP requests that come in. So in order to do that, we use the Express application to create a server, and we're going to save that server in a variable called server. Okay. And the way that Express creates and returns a server for us is just you call it as a function. And the default function will return a server object that we can then use. That server function, or that server object that is returned, has a number of different functions on it. One of them is called listen, right? So what this is going to do is start our server and then put it in listen mode where it's waiting for traffic to come in over the internet or over the network, right? So what we're going to do is tell it to start listening on a particular port. And in my case, I'm going to use port 4000. I'm going to talk about TCP ports here in just a minute. But the default that I'm going to use is 4000. And then we provide a callback function that is executed once the server begins listening. And all we're going to do in this case is just log something to the console and say, we'll just log something that tells us that our server is now listening on port 4000. Okay. I'm going to comment that. Someone asks, how do I get my terminals on the side like that? It's a configuration setting in VS Code. Maybe during a break I can dig that up, or someone else can for you. I can't remember exactly what it is, but there's a way to get it to go over there. I'll have to look it up. I can't remember exactly how to do it, but I'll find out for you and let you know, or someone else can help out. Then someone asks, can we still use a jsconfig.json file instead of base URL in order to shorten the require paths? The require paths. So in order to shorten these paths, that's a good question. I'll have to check on that for you as well. I'm not sure, but I will find out and let you know. I'm going to leave that question up so that we can dig into that. For the most part, the require paths are local, so I don't know necessarily about shortening them depending on the structure of your code. So if I had a file that was in then I could do just like that. So it's pretty short as it is because it's just relative to the project. If it's in a subfolder like data, then you just type the path to it like that. I'll check on the jsconfig.json file for you. It's not something that I use very often. All right. So this is how we get a server up and running. So let's talk a little bit about TCP and about port 4000, what that is. I brought up a web page, and I'll post a link to this in Slack so that you guys can go to this if you're interested. Someone already commented that jsconfig.json will not work in Node. That you can use it, do something else to get absolute path. So there's an answer there. So essentially what TCP is, when you look at the TCP IP traffic, it's essentially bits and bytes that move across the network, right? Whether it's a local network or over the internet. And IP, or the internet protocol, is what allows packets to get from where they originate to where they're intended. That's what an IP address is for. And that's essentially what the IP packet itself does. The IP packet structure has what's known as a payload inside of it. So you can put a lot of different things inside an IP packet. And one of the things you can put inside an IP packet is a TCP packet, which again is just a collection of bits that follow a certain format. And what you get with that is a source port and a destination port that are listed with the TCP packet. And inside the TCP packet, this data section, so there's a whole bunch of other stuff that manage how the TCP packet works. It's something called a connection-oriented protocol, which again, we're not going to go into. This sliding window, which allows you to change the size of the packet. It allows them to be chopped up and reassembled later. And that's all the wonder of the internet and how it's so resilient. But inside the data portion of this TCP packet is where our HTTP packet will go. And our HTTP packet or data is just a bunch of text, right? So all of this other stuff is used to help determine what application is going to process that packet or that data once it arrives at its destination. So the source port is when the server responds, it knows that it needs to send the response back to that source port. That's what allows the client machine to know which application that incoming packet is supposed to be given to, right? So likewise, when we start our server, we can say essentially that our source port is 4000 on our machine because that's what we specified it. And any client that's going to be sending information to us, they need to make sure that in their TCP packet, they have 4000 listed as the destination port. And once this packet hits our machine, it comes in through our network card, then the network software, the protocol stack, takes a look at this destination port, and in memory, it has a list of all the applications that are listening for incoming traffic. And we may have multiple applications running on our server that are listening for incoming traffic. And in order to make sure that the traffic gets to the right application, that's what these ports are for. There are 65,000 plus ports that can be used, and many of them are considered to be what are known as well-known ports. A couple of them you're probably already familiar with. For example, the well-known port for a web server for HTTP traffic is typically port 80. A well-known port for HTTPS or encrypted HTTP traffic is port 443. So those are well-known ports that everyone kind of agrees that when you start a web server, you can assume that communicating with that web server is likely going to happen on port 80 or on port 443. There are other well-known ports. You can look them up. Somebody mentioned port 23. That's an FTP port. There are other ports that, port 25 is SMTP. There's a secure SMTP port that's different. There's also secure FTP ports. There are many, many other ports that are well known. And typically what we want to do is make sure that when we're developing on our machine, where there may be other applications that are listening for TCP traffic, that we choose a port to listen on that's not already being used. Port 4000 is not a well-known port. And so it's a pretty good bet that there's not anything already listening on port 4000 on our machine. If there were, when we tried running the server would fail to be able to set up a listen on that port, and it would notify us and it would say, I can't listen on that port because there's already an application that's using that port, right? So that's essentially all that port is to make it so that when traffic comes into our machine, our TCP/IP protocol stack knows which application that traffic is supposed to be for. And that's what allows us to have multiple TCP/IP applications running on a single machine at the same time. Okay, so if we look here, we can see that we're choosing port 4000. There are many other ports we could choose. It could be 8000, it could be 4040, it could be 8080. You often will see applications that use 8080, even though it's not a well-known port. It's one that you will find in the Java world, for example. Tomcat, I think, is an HTTP type server that will listen on port 8080, and there are many others. So just be aware that that's what that is. This is an arbitrary number that's in the range of 1 to 65,000 plus. It's 2 to the 16th power, whatever that number is. And we just happen to choose 4,000 here. Okay. All right, so this is what's going to give us our server. So I'm going to save this, and then we can start our server up, and you'll notice that we get our console saying that the server is now listening, right? So if I go into my browser, and because my browser is running on the same machine, the IP address that I'm going to use is localhost, and then the syntax that we can use in the browser is a colon. So if I don't use a colon, what the browser is going to do is direct that traffic to port 80, because that's the well-known port for HTTP traffic for a web server. But if I want that traffic to go to a specific port, then I do colon and I indicate what the port number is. And in our case, we want it to be port 4000 because that's where our server is listening, right? So if I do that, you'll notice that I get an error. It says cannot get slash, right? So it's like I'm really trying to get slash, and it says cannot get slash. If I don't put a slash in, that's the default, right? If we go back over to our server and stop it, so it's no longer listening on that port, and then go back into our browser and try to refresh this, you'll notice that I get a completely different error. It says this site can't be reached, right? So that's the server a machine basically responding to the client. It's saying, you've asked for me to direct this to port 4000, and I don't have anybody listening on that port at all. Whereas when our server is running, we do have something listening on port 4000, and what's responding in this case is Express. Express is actually receiving the request, and it's saying, I get that you're asking for this, you're doing an HTTP GET, and you're asking for the root document, but I don't have anything that tells me what to do with that. And we're going to talk about that today, and that's what basically our whole purpose and function today is to get through that, right? So that's the whole point of that. Okay, so we're going to kind of kick it into a little bit of a higher gear as we kind of dive through. building our API server. So now that we're listening on port 4000, we want to be able to take incoming requests, HTTP requests, and we want to teach our Express server or program our Express server to be able to manage and handle those requests. Okay, so you'll notice that by default, we're trying to get the default, the root, just a slash. And so what we want to do is create a function that will execute when a request comes in for the root document. So when a request comes in, an HTTP GET request comes in for the root document on port 4000, we want to write code that will execute in that case. And the way that we do that is on the server object is a function called GET. And essentially what this does is it creates code. We're going to be able to create a callback here that will be executed when a GET request comes in for the root document. So we can specify what path or route this particular function should be executed on. So essentially we're saying, hey server, when a GET request comes in for this path, then I want you to execute this callback function, okay? Now, when the callback function is executed, the server is going to give us a couple of different parameters. It's going to give us a rec parameter and a res parameter. Keep calling them parameters. These parameters are the request object, which contains information about the request, and we're going to see how that becomes very handy for us. And it also gives us a response object. Okay, so we could call these request and response. Convention is to call them rec and res because it's short, but they're arbitrary. Because this is a callback function, we can call these parameters whatever we want to call them. Just know that the first one is an object that will contain information about the request, and the second one will contain information that we can then modify in order to send back a response. Okay, a couple of different questions. Does the server.listen have to be defined before you start writing your routes? It should be at the top, yes. I got stuck, second question, and had to fix my node version and rollback. Can you push to master so I can pull and get caught up? I can in my own. I don't have access to the Lambda repo. You can get it off of my own if you'd like. So I'm happy to do that. But this is all the code that we have. In fact, what I can do is just post this for you in Slack. That will go in your index.js file there, and your TL can help you otherwise as well. Next question, somebody asked, sorry, let me get back into my questions. So rec/res are both objects by default. That wasn't clear before. Yes, they are objects that get passed into our callback function, right? So we're defining a callback function here, and these are the objects that get passed in. And again, they don't have to be called rec and res. It can be called whatever we want. They're just by default called rec and res, but they really are the request object and the response object. And I'm going to develop this first method using request and response, so you can kind of get used to the fact that that's what they are. But later we'll shorten it to rec and res because number one, that's what you're likely to see in sample code and in other examples. And it's also simpler to type because they're short. You'll also see these in Lambda parlance with other instructors and some of our written content referred to as the homies. I think the training kit called them that. And it's simply because you're not going to create a route handler. That's what this function is called. It's a get handler for this route. You won't create a route handler that won't include both the request and the response object. There may be other objects that we can pass in here. We're going to learn about those later. But for now, just know that you always will include at least these two. The request and the response object. Okay, so here we want to write code that is our application's response to a request that comes in on port 4000 for the get verb to that path, right? So what we're going to do, just real quickly, okay, we're just going to create, and notice when I saved that, it automatically restarted my server. So now I can go back over to my browser and I can run this. And you'll notice that it says you asked for it, but if you look at the browser, it's continuing to spin, right? And the reason why is because in our handler, we haven't sent back a response yet, right? So we have a response object that we can use to send a response back, but we're not using it right now. And so right now, the browser is still waiting for that response. And it'll eventually time out because it has it built into the browser to say, I'm tired of waiting and I'm going to assume that the server's broken and isn't going to respond to me, right? So I'm going to go ahead and stop my server, and that will automatically break my client and tell my client that you're not able to get a response back. So what we want to do next is actually send a response back, okay? Response.send. We'll send back hello world. Okay, so send is a method on the response object that we can call that will send information back. So I'm going to save this, start our server up, and then come back over here and execute. And you'll notice it actually automatically refreshed for me. And now we're getting our response back. Okay. All right. Another couple of questions. Or a single question. Are servers women? They can't be men because they listen. Haha, that's really funny. Also, they get what they're listening for. You know, they have to be developed properly in order to listen and respond well. So that's, I'm just going with the joke. Don't take that personally. It's just, but it is very funny. Thank you for a little bit of levity. All right. So, so now we're actually responding. And so hopefully you're able to kind of catch up with us, that we have that in place. What we want to do now is we're going to, I was going to have you do a little exercise, but I'm afraid we're running a little low on time, so I'm going to skip that. I may come back to it if we have time, but I want to get to the point where we're interacting with our database. And then I may, if we get through this pretty quickly, I may give you just a short little exercise to develop your own get method that returns the time. So now that we know how to respond when we're requesting a particular path, note that we can oop, I misdid that. We can have multiple get handlers, right? So we've got one get handler for this path, and we have another get handler for a different path. Turns out you can actually have multiple get handlers for the same path, and they'll be stacked onto one another, and you can ensure that they're all executed in a particular order. We'll learn how to do that later in the course as we learn more about Express. But for today, just know that we've got a handler for this path, and now we're going to create a different handler for /hubs. Now, a hub is just part of our data model, right? So what they're creating here is, it's like we're trying to create a chat application, and whoever designed our data model for the chat application decided that a chat hub is an object that exists in our database. And so what we want to do is create an API that allows an API developer to retrieve a list of hubs that exist in our database. Okay, and I'm not sure exactly what a hub is, but whoever designed it created it such that that there are hubs in our database, and we want to be able to allow developers that are using our API to list those, as well as create them and delete them and manage them. And so that's what we're going to be going through now. Okay, so when we talk about CRUD, okay, that's an acronym that we've used before. It's an acronym that stands for create, read, update, and delete. Some people like to say destroy. I prefer delete. And so a CRUD API is an API that includes methods that allow you to create, read, update, and delete. So right now what we're going to work on is the read portion, right? So we'll put this in here. That will allow us to read hubs out of the database, okay? Well, in order to do that, we need to be able to interface with our database. And what that's going to mean is that we need to bring in this Hubs model file. Okay, Hubs model contains a number of different functions. If you look at them here, in fact, I'll come to this outline over here. These are functions that are created inside this Hubs model file. There's an add function, a find by ID function, a remove function, and an update function. And each one of these connects to interface with our SQLite database. Okay, notice that it uses this connects file, and we're going to learn how to do these later, but just be aware that that's what's happening here. And so by having this file, it kind of abstracts that away for us so that we don't have to worry about connects. We just call these functions. And you'll notice that each of these functions returns a promise, right? So if you're familiar with async, and I'm going to, in a later course, we'll cover async and await as opposed to the .then catch syntax for dealing with promises. But just be aware that each one of these functions does return a promise, okay? And so we're going to need to be able to handle it as a promise. But you'll notice that we've got this find method, and if we look at it, you'll see that what it does is it essentially does a query on our database for the Hubs table and returns everything. It returns all the rows that comes back from it, right? So all we need to do is this find object, and it's not required for us to pass in any information to it. This is all optional. So if we don't pass in a particular query, then what it will find is everything in the database, right? So in order for us to be able to call this find function, we need to be able to import what's being exported here, all these different methods. So in our index file, at the top, we'll just call it DB for database. And we'll do a require, and it's in the data directory, and it's this Hubs model.js file. Okay, and that'll bring in a variable called DB, upon which we can call find by ID, add, remove, and update, right? So in our case, what we want to do is we want to do a find. Now, because it returns a promise, after the find returns, and the reason why we want to do it as a promise is because it's asynchronous. We don't know exactly how long the database function is going to take. And in our case, it would be pretty quick, but you can never tell because it could be on a server. Our then clause is going to receive what is returned by the find method, right? So we'll just call them hubs because that's what comes back. And what we want to do with hubs is pass it into a callback. And in our case, we want to send back a response, and that response needs to include the data, right? So before we did just send, and we sent back text. But in our case, we want to send it back formatted as JSON data. So it turns out that there's a helper function that we can use that will take that data and turn it into JSON text so that what gets sent back is JSON. And that's really important in an API because that will allow the API user to have a predictable format in which it's going to receive the data. If you dig into understanding how to build a REST API, you'll understand that a really good REST API will allow the client to specify what format they want the data to be returned in. And in many cases, you'll find that they support both JSON and XML. In our case, we're only going to support JSON. But we do need to be able to take what comes back from our database method and format it as JSON, right? So JSON, and then we can pass in our Hubs object, right? One of the things that I didn't really cover before is with respect to HTTP, when you send a request, you specify a verb, and there are a number of them, but the ones that we're dealing with that work with CRUD include get for reading, post for creating, put for updating, and delete for delete, right? So I'll put them out so you can see. So our HTTP methods that correspond with each one of these are these. And so when we did a get, that's why we're doing a get here. And that's what we do to read data. With HTTP, the response comes back with what's known as a response code. And the code indicates to the client whether the request was successfully handled or not. If you study up on HTTP response codes, you'll notice that there's a number of them. In fact, I'm going to actually go back and look at this Wikipedia once a little better. It's got some information here that kind of describes it, and each of these codes is in a different category. There's 1XX codes, 2XX codes, 3XX, 4XX, and 5XX. All right, it kind of explains what they're for. For a successful response, we typically want to return a 200. There could be a 202 and a 203. There are other 200 level responses that mean different things, but they all are successful response codes. Okay, well, when we did this send, Express automatically for us set the response code to 200 so that when the client got it, it got the response code of 200. In our case here, we want to be able to specify what the response code is, right? And we do that with what's known as the status method, where we specify what response code we want to pass. And then we can chain the JSON method onto it, which will then format. So we're basically saying in our response method, we want to set the status to 200, and then we want to call JSON and send a JSON formatted version of this object back. Okay. So that's how we handle this. So we're going to do a db.find. It's going to return a promise, and when that when it completes, it will give us the hubs that it found, and then be able to send it back. Okay. If, however, there's an error, if our database method returns an error, then we want to do our catch clause as part of our promise, right? So the error object will come into catch, and in this case, we want to do a response of 500, which is basically us saying there's a problem on our end, we want to send back a JSON object that specifies what that problem is so that the client can see it. And in our case, we're going to send back a message that is our error object, and then we'll also send back a success parameter that says false. And that basically will help the client to know, based on the 500, that it was a failure, and then the message will include our error, and then it has this parameter that we can do. And this is all arbitrary. We can specify what we want to include in the response, but this is critical. We do want to send back a 500. Okay. Someone's asking for package.json. Put that, let's see, where is my Slack? There we go. There's a package.json file. Sorry, I didn't format it. Hope that's okay. And then another question, oops, that was asked. Can we make a GET request to another API for data? Yes, you can. So if as part of your response, you need to call to another process, you can absolutely do that. So from within an Express handler, you can call another API to get data. Tabs or spaces. I personally prefer spaces. I don't know if you're asking for my opinion, but I prefer spaces. I'm a little confused about .then and the hubs and the callback function. Can you explain that a little more? What is the hubs before the arrow coming from? Okay. So when you're dealing with promises, you call the method that returns a promise, and then you specify to that call a function, right? So this is a callback function that we're passing in the dot then clause, and we're basically saying to the promise, when you complete or when you resolve, call this function. And the promise will take the result of this and pass it into our function. So I could do it like this, if that helps. So we're basically saying, here's a function that takes a parameter, and the name of the parameter is arbitrary. I happen to just call it hubs. But what's going to happen is the find method, when it resolves, will take its results and pass it into our callback function as a parameter. So that's where it's coming from. It's coming from the find method. Likewise with catch, if there's an error that gets thrown from our find method, it's going to call this function that we created and pass in the error information as a parameter. Okay, so here we're just defining a function and passing that function into the catch clause and saying, if there's an error that is thrown, call this function and place the error as a parameter as a parameter to our callback. So hopefully that helps. Okay. All right. So here's our server.get to /hubs. I'm going to save this. And then if I go back over to my application here, and I do a get /hubs, then what I get back is this JSON object. Now you'll notice that for mine, it automatically formats it, and that's because I have a Chrome extension that formats JSON data. What you might get back is just a big string that has all of the JSON data in it together, which is totally fine. That's correct. That's the correct response. Mine is just being formatted by an extension that I have that automatically formats JSON data when it comes in. That just helps me to read it a little easier. I'll try to post what that is in my notes after class, so that anybody that's interested in what that extension is, you can get it. Okay, so here we can see we're getting our data back, and so that response is working. We don't really have an easy way or time at this point to test the error condition, but that's what's happening there. Okay. So thank you for posting that question. I'll leave it here to make sure to put the link to you for that to you. Normally at this point I would take a break, but we're running behind, and so I apologize for those of you that prefer a break, but I'm assuming that you would prefer to end on time rather than to have a break. So I'm just going to kind of buzz through these other functions that we need to do. We're going to move on to the create portion, which means we need to create a post handler. Okay. And the way we do that is we call server.post. Okay. And in here, again, we're going to put in the path that we want to handle. We want this function to run with. And we need our request and response. And then we're going to pass in a callback that's going to receive these to work with. Okay, so now this is where we're going to create a hub, and this is where we're going to pop over to Postman and take a peek at what we want to do here. Because if we look at the browser, right from here, you'll notice that there's nothing here that lets us specify what the HTTP verb is. Right, the verb that we're using is get, and that's by default because that's what browsers do, is they get information. But if we wanted to pass a different verb like post, there are some things that you can do within an HTML file, like a form submission, that will cause the browser to do a post. But we don't have a form to fill out, so we don't have a way to get data to pass into the server other than here on the URL. But in a post, we want to include the data that's going into the server in the request body. And this is where Postman comes in, because Postman essentially allows us, you can see we can do a get, right? So if I do localhost 4000 /hubs, and do a get, you'll see we get the same data back, right, that I got before. But I also have the ability to do a post, right? So I can do a post to this same URL, and in order to pass data in, because again, what I want to do here is I want to create a new object, and I have to give the information to the server so it knows what object to create. In order to pass it in, I want to choose body, and there's a number of different formats of our body that we can specify. And what these really what they control is these headers, right? So if I look at the headers, there's some temporary headers, but there's no specific headers here. But if I go into body and say form data, for example, you'll notice that, let's see. Let me try. If I do body and this, yeah, then it adds this header, this content type header that says that the content is XWWW form URL encoded. This is basically a hint to the server as to what it can expect in the body. So the server knows how to parse it or how to manage it, right? So if I come back over here to body and I say, you know, binary, for example, then this doesn't actually change. So some of these don't actually have a header, but if I choose raw and text, then you'll notice that this changes, Postman automatically changes this header type to text/plain. Now, headers are just values that are part of the HTTP request. So when the HTTP request goes in addition to other data that we send it, these headers are there to help different routers control how to route it. Different cache systems know how to cache it. It allows the server to know how to process it. And so one of the things that we can tell the server is what format the body is supposed to be in. Okay, so text/plain is one, but what we want to do is we want to choose raw, and then we want to say JSON, right? So then when we look at our header, it's going to change that header type for the content type to JSON, right? So now that I'm here, when I come over to the body, I can specify a JSON object, and I want to stringify it because that's how it has to be in order to pass it in HTTP, okay? So I want to create a new hub, and its name, I want it to be, I'll just say my shiny new hub, okay? And that's all that I have to pass in. I happen to know this about our database, is as long as I supply a name, it can create a new hub for me, okay? So when I come back over to look at my post, when I make that, send that in, that data that I'm sending in is going to be available to me in my request object, okay? So here what I want to do is get the information, and I'm going to pull it off of the request object in a parameter called body. Okay, so Express is going to take care of that for me. When it gets the post request, it's going to take the body of that post request and then save it in this property of the request object, and then pass me the request object so that I can then have access to it, right? And then with that information, I can call the DB add method, and what I want to do is pass in my hub info. And again, this is going to return a promise. And so once I'm done adding it, I want to be able to send back a response, right? So what I happen to know about the add method, when I look at the add method, is that it returns, so after it does the adding for me, this insert, it's going to find it in the database by calling this find by ID method, and then return it to me. So I know that I'm going to basically get back the object that I asked it to add. This is a common thing you'll find in APIs, is that when you insert information, the API will return it back to you so that you can examine it and make sure that it was inserted properly. That's right. So what I'm going to get back is my hub object. I'll use the same syntax as I did before just to make it a little simpler to understand. And I'm going to pass that hub object into a function that I'm going to call. And in this case, I'm going to set my status to 201. which is an HTTP status in a REST API that's standard for success in adding data, right? So instead of 200, we'll do 201. It still means success, but it means you successfully added it. And then I want to send back a JSON formatted object that says success true, and I want to JSON format the hub object that I got back, from the database. And then, of course, I want to handle any errors that come in. In this case, I'm going to set my status to 500, and then send back a JSON object that says success false, and I'll pass in the error information there. Okay. All right. So that should be all that we need in this post method. So I've now saved it and restarted my server. And if I come over to Postman, I can then execute this post request to localhost 4000 hubs. That's what's going to make Express run this function, because it's a post to /hubs. And then I'm passing in this information. It's formatted as JSON. We can tell by looking at this header, right? So body raw JSON type. And then so it should be able to manage that. So if I click on send here, you'll notice that I get back an error. It says success false, and then here's my error object. Okay, SQLite misuse. Okay. The reason why that happened is because although we are getting back, or although we're sending in JSON information, we're not doing anything on the Express side to handle the fact that there's a JSON header, right? So one of the things we're going to learn about later on is something called middleware. Middleware is basically the ability to create handlers that are executed in order. So instead of just the one handler at the end, there could be things that happen in the middle that manipulate our data or validate it somehow. And one of those things we want to be able to do is we're going to basically parse that stringified JSON object and turn it into an actual JSON object, right? So if I were to, let me comment this out. If I were to come back down here, now that I've got this body here, all right, if I put that out to the console, we save it, come back over to my Postman and re-attempt this. Again, I get my false back. You'll notice that the body is undefined. We don't have a JSON object. We need to tell Express to take that stringified JSON object in the body and convert it into an actual JSON object. And the way that we do that is by using a piece of middleware that comes from the Express system, and it's a function called JSON. Okay, and we're going to learn about middleware later, but it's necessary for us to do this so that it'll take that JSON, stringified JSON body and turn it into an actual object. So now if I save this and then go back into Postman and execute this, now you'll notice that I get a success true. It passes back the hub that was created for me, which has an ID that was created for me, the name I passed in, plus some other values that indicate when it was created and updated that are automatically saved to the database for me. Right? And if I come back over here and look, you'll see that the body is now an actual object that contains the data that was passed in. Okay. And by the way, when class is done, I will send you a link to my GitHub repo that has this code with a bunch of extra notes that will basically rehash that stuff that we've covered here today. So if it seems like we're going kind of fast, you'll be able to go back over it and catch that. And previous classes have found that to be really helpful. So I'll make sure you guys have access to that. Okay. So now that we've got 6 minutes to get through the rest of this, now we've got our read, we've got our create. Now we want to do a delete. Okay. So if I do a server dot, I'm going to call a particular function here or method that's on the server object, right? Using Slack, somebody respond and tell me what you think the name of the function is that we're going to call here in order to create a handler for the delete HTTP method. So put that in Slack. Okay, delete, delete, delete. Everyone's got it, right? It's not put. We're going to do put later when we do an update. But for delete, we want to do the delete method. Okay. Okay, so delete is the right answer. So we're going to do server.delete. And again, here we need to specify a path, but we don't want to delete everything. So /hubs, we want to delete a particular record. So /hubs would represent, we would think, everything. But what we want to do rather is put an ID in after hub. So one of the ID numbers, we want to be able to say delete this particular record, right? The challenge is that ID can be part of the actual path and it's hard coded. What we want to be able to do is indicate to Express that ID is actually a parameter, that whatever comes after the / after hubs is going to be an ID number. So if you remember doing routes in React, it's a very similar concept, right? So :ID is a parameter that's going to be replaced. The ID object or variable will be replaced with whatever comes after the / after hubs. And so again, we want to do a rec and a res. And what we want to be able to do is take this ID and pull it out of that. So what we find is that the ID object, I'm going to do it this way. Is a property on an object called params in the request object. Okay, and by destructuring it this way, we can just take the ID, a value out of params and assign it to a variable called ID. Okay. Now that we have that, we can call db.remove, which is the method in our database, and pass in the ID. And because it's a promise, we want to do then. And if we look at our remove method, you'll notice that what gets returned, it says removed. Okay, so when we look at find by ID, we're going to get back what was removed. Okay, so what we want to do in this case is we'll just call it the deleted hub, and we're going to pass that into a callback function. What we really want to do is here we want to check and make sure it was properly deleted. So we could say if deleted hub exists, then what we want to do is send back a status of 204, which is a common code that basically means success, but we're not actually sending any data back. And then there's a particular method we can use called end, which basically tells Express, you know, nothing else is going to handle this. We just want to send back the response as it is. It's very much like the send method, but with no data. Okay. But if it failed to delete, which could happen because they pass in an invalid ID, right? We want to set the status to 404, which is this common status for document not found. But in the REST API, it basically means what you requested doesn't exist. So the difference between 400 level errors and 500 level errors is that a 400 level error means the client did something wrong. The client passed in bad data. A 500 level error means there was something wrong on our side, and no matter what the client does, there's nothing the client could change to make us be different. We're broken on our end, right? But in this case, we're checking to see if we were actually deleted something, and if not, we're assuming that it's because they passed in a bad ID, and we want to let them know, hey, this is your fault. This is a 400 level error, right? And then we can pass back a JSON object that says, we'll do it this way. Okay. So we're going to set the status to 400 and send back a JSON object. And I apologize, guys. We're probably going to go a little bit over. If you need to drop off, we have it recorded, and I'm going to pass in notes. But we'll probably go about 5 minutes over class time today. And I normally don't do that. It's a point of concern for me, but I apologize. I don't want to not cover what comes next. So if you can stick around, please do. And if not, you can catch it on the recording and in my notes. Okay. If, however, we throw an error on our side, then we want to do a 500 level error. And we'll pass in a JSON that says that success was false. What I need to do is pass in this, and then I pass in the error object. Okay, let me just check what I've got here. Okay. Thanks for understanding, guys. I appreciate it. All right. All right. So before I actually try this, I want to get to some of the questions that you guys have been asking. Just an opinion, but often some of us run to the restroom on our 5-minute break and would rather stay 5 minutes over. Thanks for suggesting that. I'll keep that in mind for next time. Thank you for that. The ID is generated automatically by Express. It's not generated by Express. The ID is actually generated by our database, right? So it's actually something we'll learn about when we learn about data persistence, but when you insert an object into a database, the database itself assigns an ID for us. And so that's where it's happening, is at the database. Is it just me, but are we not able to see the bottom of his screen? Let me know if you guys are not able to see. Down here, you should see a blue line that says line 44, column 17, and so forth. So let me know if that's not the case, and I'll see what I can do there. All right. Back to here. All right, so here I'm going to save this. That'll automatically restart my server, and then I'll come back over to hubs, and we just added one called 19. If I do this get with hubs and I send it in, you'll see that it gets returned, right? But if I do a delete /hubs/19, then you'll notice I get a 400 level or 204 level response, which is success. We're not actually passing any data back. Remember, we just did .end, right? Right here. So we're not actually sending any response back. This should be enough to the client to let the client know your delete request succeeded. Okay. So we get that back. If I were to pass in an invalid ID that doesn't exist, right? So again, if we do this get, you'll notice I don't, this is what I meant to do. It didn't actually do anything. In any case, when I try to do the delete, you'll notice I get this message back that says I could not find ID equals 199, and my result is a 404 rather than a 500. Okay, so that's why here we're checking to see if our deleted hub exists, and if not, we're assuming it's because they passed in a bad ID. There are other things we could do to validate that. We're keeping this simple on purpose, but it's not a bad assumption on our part. Whereas if it's an error that was thrown from within the remove function, we're going to assume there's a problem on our side. Maybe the database isn't available, or there's some problem with the network or something, in which case it doesn't matter what the client does. The problem's on our end, and we want to pass back a 500 level error. Okay? So we've got read, we've got create, we've got delete. Now we want to do update. Okay? And the method that we use to do updates is the put method, okay? And it's going to work very similar to the delete, in that when we do an update, we're going to update a single record, so we want to pass in the ID of what it is that we're updating. And we're going to do a rec res. And so here, we want to do something similar, where we need to pull out the ID. By the way, another way to do this is we could do const ID equals rec.params.id if we wanted to. In fact, I'll keep it this way just as a contrast to what we did before. But in addition to the ID, which tells us which one we want to update, we also need to get the body, which contains the new information we're updating with, right? So a put is kind of like a combination between a post and a delete, in that we need to send information in the body, but we also need to identify a particular ID that we're modifying, right? So in this case, we're going to get hub info out of the rec body. Okay, and together with these, if we look at our hub model, we can see we've got this update method that takes the ID and the changes, right? So in this case, we can do db.update ID changes, and again, it's a promise, so we're going to do a then clause, which if we look at it, it's going to do a return find by ID, so it's going to return the object that it updated. Right, so again, we can call this a hub. And in this case, we want to do similar to what we did before. We want to say if hub, then we're going to do a response.status of 200. And JSON object will say success is true. And we will pass back the hub that we modified. Otherwise, we're going to assume that they typed in a bad ID. We'll do a 404, which basically means the ID that you're trying to modify doesn't exist, right? And by the way, the format of this JSON object and exactly what we send back is completely arbitrary. We just want it to be useful. We want it to be something that the client developer can understand and actually make use of, okay, in this case. So then we also want to do a catch in case there's an error on our side. And we're going to pass that into a function. And here we'll set the status to 500. And we'll pass back a JSON object. We'll pass back the error information. Okay. So there's our put. So I'll save that. And then if I go back over to Postman, and we'll do a new method here, we'll do a put localhost 4000 hubs. And if we look at localhost 4000 hubs, if we get those, we can see what IDs exist. In our case, let's modify this number 17. So we're going to do /hub/17. And we want a body. We want it to be JSON. And in our case, we're just going to change the name. Let's call it a new name for my hub. And we'll send that in and get an error. Did I save? Changes is not defined. Oh, I called it changes here, and it's not changes, it's hub info. So we'll try this again. Okay, then you'll see that it's true, and it sent us back the object that we modified, ID 17, with our new name. And if I come back to my get and re-execute it, then you'll notice I get my new name back. Okay. All right. So that's it. We're more than 5 minutes over. A little exercise you could do if you wanted to try, and I'll put this in here, and you can, is to do a server.get for, instead of getting everything, just do right? So then you could fill that out and make it do what it needs to do using the methods from hubs-model, right, and returning the right data. So I'll keep this in there so that as a prompt to you when you get my notes and the GitHub repo that I will have that you can then download later. And with that, again, apologies for going over. We'll try not to let it happen again. I don't think it will. Hopefully this has been helpful. We've covered a lot. So going back to the objectives for today, we wanted to make sure that we learned what Node was, what Express was, build an API that can get, and actually we did an API that does all the CRUD things, and then using Postman to manually test. We'll get more familiar with this as we go, and there's a lot more that we're going to learn as we get through this. So hopefully you guys enjoyed tonight. Look forward to me dropping my repo with my notes. Those will come within the next hour or so. And we'll catch you guys on Thursday. Have a great night. And by the way, these additional questions, I will post answers in Slack. So it says show your Postman settings for a post request one more time. I'll leave that up here just for a little bit, and then I'll end the session. So for post, it's you do post, you do body, raw, JSON, and then just put that information in. All right, guys, have a great night. We'll catch you guys on Thursday.